Much like in the tutorial video, the first thing we will do with our data set is to vectorize it. First, we make sure we are in pre-processing, select the text. We then navigate to string to word vector. By default, it has a prune rate of 1000. We're going to do something kind of random here and explore and set our words to keep to 200. And then we will apply that and let that run for a minute, and now we have the 200 top words pruned from our dataset. To dig a little further into manipulating our dataset, we pull up the options menu from string to word vector, and we see all of our options here. I'm going to go ahead and choose a tokenizer. Now, from the description given in the tutorial, I like the n-gram tokenizer and what it seems to be capable of. I also am going to set the output word count to true. And why not? We'll throw in a stop word handler, and we are going to use their rainbow table setting. So I'm going to go ahead and save that. Apply the new changes to my dataset, and we're ready to go. Next, I wanted to play around a little bit with clustering and some unsupervised modeling for my data. So I come up here to the clusters tab. I'm going to be kind of simple and boring and choose a simple k-means. And by default, the number of clusters is going to be 2, which makes sense for our data set since we have zeros and ones representing either positive or negative reviews. So I will be okay with that for the moment. And click OK. And as we see, we have 2 clusters here. All of our data has been clustered. Now, what if I don't want to look at numbers? Well, right here, I can visualize the cluster assignments. I'll make this a bit bigger. We can select different X and Y values to cluster. Right now, it is taking our classes against instant number. So I will take, let's check the word back against another. And here we see no clustering. Now let's see if we can get another one. So as we can see, just by kind of visualizing the cluster data here, it might not be the best way to cluster these types of attributes. And perhaps clustering is not the most effective method of mining data for this particular set. Next, for fun, we're going to move over into the classifiers. We make sure that we are actually working on our nominal classes. And in here we can see the different classifiers. Now, to start with, I'm going to use naive Bayes multi-nominal text because we're working with text. I figure why not? Take a look and see some of the options we have in here. And for now, I'm going to change the norm to 2. Decimal places, I don't need super accuracy, so I'll change that to 1. And minimum word frequency, I only care about words that show up a lot. So we'll say 4. Apply that. Cross-validation, we'll up that to 15 folds, and run. And we can see right now we have a horrible classification rate, but we're having a great time poking around and seeing different features that we can build with. So after naive Bayes, I'm going to try a random forest. Now, I attempted a random forest with a huge number of iterations on it just a moment ago, and found out that that was going to take quite a while. So we are going to down the number of iterations to 10, down the bag size and batch size, still keep the max depth relatively high. We're going to change that to 50 and apply that and see. There we go. That is going much faster. And now we can see, even just with a few tweaks, we upped our accuracy by about 10%. So what if I wanted to explore attributes and information I can get from the attributes? So I will select attributes, and for now I am going to explore principal components. It went ahead and chose a ranker for me. Thank you very much, Weka. I will use the full training set because it doesn't give me another option not to. But what I will do is I will set the center data to true, and maximum attribute names, I'm going to down that to 3. Variance covered, that seems to be an appropriate amount. Transform back to original, no thank you. Okay, and we will run this. And here we are. So now at the bottom, we have a nice list of all of our attributes, the principal components, and their ranking based on our attribute selector. Now, say that I was more interested in information gain. So I will select information gain about our attributes. I would like to check for missing capabilities. Go ahead and apply that, and I'll just throw in a cross-validation of 10 folds just to be clean about it. We can see that one is a lot faster, and now it spit out for us the average merit, rank, and which attribute, which word it chose that gives the most information gain based on the word, and then the attribute number. So clearly something like bad or great, it's seeing as having very high information gain.